Welcome to Ask and Learn.
In this problem, a room is to be heated by 1 ton of hot water, which is contained in a tank that is placed in the room. We want to calculate the minimum initial temperature of the water if it is to meet the heating requirements of this room for a 24-hour period. Now we assume that water is an incompressible substance with constant specific heat. Air is an ideal gas. The energy stored in the container itself is negligible. The room is maintained at 20 degrees Celsius at all times. And finally, that the hot water is to meet the heating requirements of this room for a 24-hour period. The specific heat of water at room temperature from our table is C is equal to 4.18 kilojoule per kg degree Celsius. The first thing we'll do is calculate the heat loss from the room in a 24-hour period. So we'll call this Q subscript loss, is equal to 6,000 kilojoules per hour times a period of 24 hours. And so we get the heat loss in one day, 24 hours, to be 144,000 kilojoules. Now let's take the contents of the room, including the water, as our system. We can write an energy balance equation for the system. E in minus E out is equal to the change in energy of the system, delta E. Now the only energy in and out in terms of heat, work, etc. is the heat transfer out of the room. The room is losing heat to the outside. So that's negative Q out is equal to a change in internal energy of the room, delta U. Now this is equal to the change in internal energy of the water in the room plus the change in internal energy of the air in the room. So now remember that the air temperature stays constant, so delta U for air is 0. There's no change in internal energy since the temperature change is 0, and so minus Q out is simply the change in internal energy of the water, which we can write as MC delta T, the change in temperature for the water. So the mass of water times its specific heat times its change in temperature. And that will tell us the heat that is leaving the room. Now, we actually have all these values besides the initial temperature T1, which we wish to solve for. So we can substitute them in. So the heat out, which is the heat loss, is 144,000 kilojoules. We'll suppress the units here. So that's minus. And that's equal to the mass of water, 1,000 kilograms, times C, which is 4.18 in SI units, kilojoule per kg degree Celsius, times the change in temperature of 20 degrees Celsius minus the initial temperature T1. And so we can rearrange this equation and find this initial temperature T1, which is the temperature of the water when it is first brought into the room, to be 54.5 degrees Celsius.